Today's topic is 555 IC tutorials. We have observed that it is possible to create a relaxation oscillator using individual components like multivibrators and CMOS oscillators to generate simple square wave output waveforms. However, there are also specialized integrated circuits like the 555 timer that are specifically designed to accurately produce the desired output waveform by incorporating only a few additional timing components. One device that has been present in the electronics industry for a long time and has become a standard is the 555 timer oscillator, commonly known as the 555 timer. This timer is named after the three internally connected 5 kilo ohm resistor it uses to generate reference voltage for its two comparators. The 555 timer is a cost-effective, popular, and timing device that can function as a timer to generate single pulse or long time delays, or as a relaxation oscillator that produces stable waveforms with varying duty cycles from 50 to 100%. The 555 timer chip is an 8-pin device that is highly durable and stable. It can be used as a highly accurate monostable, bistable, or astable multivibrator, allowing it to be utilized in various applications such as one-shot or delay timers, pulse generations, LED and lamp flashes, alarms and tone generations, logic clocks, frequency division, power supplies, converters, and many more. Essentially, it can be employed in any circuit that requires time control, making its potential applications limitless. The basic form of the single 555 timer chip is a bipolar 8-pin mini dual inline package device. It consists of approximately 25 transistors, 2 diodes, and 16 resistors arranged to create two comparators, a flip-flop, and a high current output stage. Additionally, there are other versions available such as the NE556 timer oscillator, which combines two individual 555 timers in a single 14-pin DIP package, and low-power CMOS versions like the 7555 and LMC555, which use MOSFET transistors instead. Pin configuration of NE555. To better understand how the 555 timer works, a simplified block diagram of its internal circuitry is provided, along with a brief explanation of each connecting pin configuration. Pin number 1 is the ground pin, which connects the 555 timer to the negative supply rail. Pin 2 is the trigger pin, serving as the negative input to comparator number 1. When a negative pulse is applied to this pin and the voltage drops below 1 by 3 VCC, the internal flip-flop is set, causing the output to switch from a low to a high state. Pin 3 is the output pin, capable of driving any TTL circuit and providing a circuit of up to 200 mA at an output voltage of approximately VCC minus 1.5 volt. This allows for direct connection of small speakers, LEDs, or motors to the output. Pin number 4 is used to reset the output state and is activated when connected to a logic 1 level. It's recommended to keep it connected to a logic 1 level when not in use to avoid unwanted resetting of the output. Pin 5 controls the timing of the 555 by overriding the voltage divider network. Applying a voltage to this pin allows independent variations of the output signal width separate from the RC timing network. When not in use, it is connected to ground through a 10 nanofarad capacitor to eliminate noise. Pin number 6 is the positive input to comparator number 2. It is used to reset the flip-flop when the applied voltage exceeds 2 by 3 VCC, causing the output to switch from a high to low state. This pin is directly connected to the RC timing circuit. Pin 7 is connected to the collector of an internal NPN transistor. It is used to discharge the timing capacitor to ground when the output at pin number 3 switches to a low state. Pin number 8 is the power supply pin, typically ranging from 4.5 volt to 15 volt for general purpose TTL 555 timers. The name 555 timer is derived from the fact that there are three 5 kilo ohm resistors connected internally, creating a voltage divider network between the supply voltage and ground. This network determines the voltage at the negative input of comparator 2 and positive input of comparator 1. The two comparators generate an output voltage based on the voltage difference at their inputs, which is determined by the charging and discharging of the external connected RC network. These comparator outputs are then connected to a flip-flop which produces a high or low output at Q based on its input. This output is used to control a high current output switching stage, driving the connected load and producing a corresponding voltage level at the output pin. The most common use of the 555 timer oscillator is as a simple astable oscillator where two resistors and a capacitor are connected to generate a fixed pulse train with a time period determined by the RC network. However, the 555 timer oscillator chip can also be connected in various ways to create monostable or bistable vibrators in addition to the more common stable multivibrator. 555 is monostable timer. The functioning and results of the 555 timer monostable are identical to the transistorized one discussed earlier in the monostable multivibrators tutorial. However, in this case, the two transistors have been substituted when the 555 timer device. Please refer for the provided circuit diagram of the 555 timer monostable. When a negative pulse with a voltage of 0 volt is applied to the trigger input of the 555 timer oscillator configured as a monostable, the internal comparator detects this input and changes the output from a low state to a high state by setting the flip-flop. As a result, the discharge transistor connected to pin number 7 is turned off, removing the short circuit across the external timing capacitor C1. This action allows the timing capacitor to begin charging through resistor R1 until the voltage across the capacitor reaches the threshold voltage of 2 by 3 VCC, which is set by the internal voltage divider network. At this point, the output of the comparator goes high and resets the flip-flop back to its original state. This in turn turns the transistor on and discharges the capacitor to ground through pin number 7. As a result, the output changes back to its original stable low value and waits for another trigger pulse to start the timing process again. Similar to before, the monostable multivibrator has only one stable state. The 555 timer is a commonly used IC designed to produce a variety of output waveforms with the addition of an external RC network. We have seen that multivibrators and CMOS oscillators can be easily constructed from discrete components to produce relaxation oscillators for generating basic square wave output waveforms. But there are also dedicated ICs such as the 555 timer especially designed to accurately produce the required output waveform with the addition of just a few extra timing components. One such device that has been around since the early days of integrated circuits and has itself become something of an industry standard is the 555 timer oscillator, which is more commonly called the 555 timer. The basic 555 timer gets its name from the fact that there are three internally connected 5 kilo ohm resistors which it uses to generate the two comparators references voltages. The 555 timer is a very cheap, popular and useful precision timing device which can act as either a simple timer to generate single pulses or long time delays, or as a relaxation oscillator producing a string of stabilized waveforms of varying duty cycles from 50 to 100%. The 555 timer chip is extremely robust and stable 8-pin device that can be operated either as a very accurate monostable, bistable or astable multivibrator to produce a variety of applications such as one-shot or delay timers, pulse generations, LED and lamp flashes, alarms and tone generation, logic clocks, frequency division, power supplies and converters, etc. In fact, any circuit that requires some form of time control, as the list is endless. Please subscribe the channel. Thank you for watching.